Hi all, good morning. Let's start Maths, grade 11, chapter 2. Chapter name is Relations and Functions, subtopic Relations. Learning objectives. After this session, learners should be able to define the concept of relations between sets, analyze the domain and codomain of a relation, solve problems involving domain and codomain. Relations. Consider the two sets P with elements A, B, C and Q, Ali, Banu, Binay, Chandra, Divya. The Cartesian product of P and Q has 15 ordered pairs which can be listed as a P into Q. A for A Ali, A Banu, A Binay, so on till C Divya. We can now obtain subset of P into Q by introducing the relation R between the first element X and the second element Y of each ordered pair X comma Y, as R, capital R is a relation indicates, such that X comma Y, such that X is the first letter of name Y, X belongs to P and Y belongs to Q. Let us see here. R is a relation X comma Y. X is the first letter of the name Y. X belongs to P, Y belongs to Q. Then R is A Ali, B Banu, B Binay, C Chandra. So here a visual representation is represented. See, whichever is in this set P, A is this letter, then name starting with this A is Ali. So we are matching the relation. B with this Banu and Binay. C Chandra. So this is his relation. Image. A relation R from non-empty set to non-empty set B is subset of Cartesian product A into B. The subset is derived by describing a relationship between the first element and the second element of ordered pairs in A into B. The second element is called the image of the first element. Domain. The set of all first elements of the ordered pairs in a relation R from the set A to set B is called the domain of the relation R. Range. The set of all second elements in a relation R from set A to set B is called a range of relation R. Codomain. The whole set B is called the codomain of relation R. So from here we can conclude that this range is subset of this codomain. For example, if A is a set with this 1 to 6 element. Now we will define a relation R from A to A by specifying that X comma Y such that Y is equals to X plus 1. So from this here, when we will do the addition of this for X, every X value we are going to get as a Y value as 2, 3, 4, 5, 6. See, therefore domain is 2, 1 to 5. When we are relating here, which is valid here, this one, 1 to 5. So this is this domain, 1, 2, 3, 4, 5. And similarly now range is from this other set here, what are the elements we have captured here? 2, 3, 4, 5, 6. So this is the range. The codomain is 1 to 6. Exercise 2.2, question number 1. Let A be a set of elements with a 1 to 14. Define a relation R from A to A by R X comma Y such that 3x minus Y is equal to 0, where X comma Y belongs to A. Write down its domain, codomain and range. Solution. Given that A is the set of elements 1 to 14 and R is a relation X with X comma Y such that 3x minus Y is equal to 0, where X comma Y belongs to set A. Now we can, from this expression 3x minus Y is equal to 0, we can say that Y is equal to 3x by transposing Y to this right hand side. You say Y is equal to 3x. If both X and Y are in set A, then X comma Y belongs to R. So we have to ensure that all the elements of the X and Y should be in A. Now let us see which is this. Value of X is 1. Then what will be value of Y? 3. Because Y is equal to 3x. So 3 1s are 3. If value of X is 2, then Y value will be 6. If value of X is 3, Y value will be 9. Similarly for 4, 12, for 5, 15, the 6, 18, 7, 21, 8, 24. Similarly for the 14 we are going to get, but still as this is not applicable, we are not getting. Thus, If we notice this one, does x comma y belongs to the set A in this given? Yes, because the range of this one will be 1 to 14. The second one, yes. Third one, yes. Fourth one, yes. Fifth one is not, because within the set A till 14 only there, but 15 is not there. That's why we are keeping there. Similarly, all it will come as a no, so that's why we are marked. So here, for a easy reference, mark with a green color. So these are the relation values. Therefore, the relation R is such that 1, 3, 2, 6, 3, 9 and 4, 12. And the domain. So the domain here is 1, 2, 3, 4. Set of elements with this 1, 2, 3, 4. Range R is set of elements with this 3, 6, 9, 12. Let us see question number 2. Define a relation R and the set n of natural numbers by R such that x comma y such that y equals to x plus 5, x is a natural number less than 4, x comma y belongs to natural number. Depict this relationship using a roster form. Write down the domain and the range. Solution. Given the relation R, x comma y such that y is equal to x plus 5, x is a natural number less than 4, x comma y belongs to natural number. We know that y is equal to x plus 5 as per the given relation. And x is less than 4, they specified here. X is natural number less than 4. Now, let's validate this one. For the value of x if less than 4 means, what is the valid application here? Valid applied values are 1, 2, 3. What should be the y value? Y is x plus 5 as per the given relation. So, x plus 5 means 1 plus 5 is 6. Next, 2 plus 5 is 7. 3 plus 5 is 8. See, if does this 1 and 6 belongs to natural numbers? Yes. 2 and 7 is yes. 3 and 8 is. Therefore, the relation R is such that a set of elements with 1, 6, 2, 7 and 3, 8. The domain is set of these x values. Therefore, domain of R is 1, 2 and 3. The range of R is 6, 7, 8. Because what are the values of y here? They are the common range. Let us see question number 3. A is equal to 1, 2, 3, 5 and B is 4, 6, 9. Define a relation R from A to B by R, x comma y. The difference between x and y is R. X belongs to A, y belongs to B. Write R in roster form. Given A is equal to 1, 2, 3, 5 and B is set with this 4, 6, 9. Now let us, to make this clear difference of this x and y is R, let us frame a table. Okay, here. For this, let us take this value of x here as a 1, the value of y as a 4 from this set now. So we can take this with a 1, 3 values. X as a 1 and y as a 4, 6, 9. So let us take 1 and 4. Then difference between the y minus x is that one. Y minus x is 3. Is it R? Yes. Next, 1 and 6. 6 minus 1 is 5. Is it R? Yes. Next, 1 and 9. 9 minus 1 is 8. So this is not R. So y minus x is not R. Now let us take this with a 2. 2 we are taking the 4, 6, 9. For this 4 minus 2 is 2. 6 minus 2 is 4. But these two numbers are even. So it's not valid. Next 2 and 9. 9 minus 2 is 7. Is it R? Yes. Next let us take with a 3. 3, 4, 3, 6 and 3, 9. 4 minus 3 is 1. 6 minus 3 is 3. 9 minus 3 is 6. Among these, first two are the R. The second one is not R. Next one. 5, 4. 4 minus 5 is minus 1. Minus 1 is a negative R number. So it's a yes. 6 minus 5 is 1. Yes. Is it R? Yes. 9 minus 5 is 4. So this is an even number. Now from this one, we can frame this R, x comma y such that the difference between x and y is R. X belongs to A and y belongs to B. Next, the relation. Here this the roster form we are writing it as for the each value 1, which are the yes are, which are highlighted with the green, they are valid. 1 and 4, 1 and 6, 2 and 9, 3 and 4, 3 and 6. Next, 5 and 4 and 5 and 6. Let us see question number 4. The figure 2.7 shows the relationship between the sets P and Q. Write this relation in set builder form and a roster form. What is its domain and range? Solution. From the figure, we can write a relationship between sets P and Q. That is, here, if we observe the difference between the 5 and 3 is 2. So 5 minus 3 is 2. 6 minus 4 is 2. and 7 minus 5 is 2, which gives the difference 2. Let the elements of set P can be denoted by X, that is X belongs to P. Let the elements of set Q be denoted by Y, so that Y belongs to Q. Therefore, we can conclude that X minus Y is 2. So, the difference between this set of elements in this and set of elements in the Q is always the difference is 2. Therefore, X minus Y is 2. In the set builder form, we can represent as a relation R such that X comma Y, X minus Y is 2 for X belongs to P and Y belongs to Q. In the roster form, we can write as per the given figure. For every X as a 5, Y we are getting the 3. For X as a 6, Y we are getting as a 4. For X as a 7, we are getting Y as a 5. So therefore, the roster form, a set of elements with 5, 3, 6, 4 and 7, 5. Domain. Domain is 5, 6, 7. The range is 3, 4, 5. Let us see question number 5. Let A is equal to 1, 2, 3, 4. Let R be a relation on A defined by with this A comma B such that A comma B belongs to set A and B exactly divisible by A. Write R in roster form, find the domain of R and find the range of R. Solution. Given A is a set of elements with 1, 2, 3, 4, 6, A comma B such that A comma B belongs to A and B is exactly divisible by A. B is exactly divisible by A, this implies. Now let us take this from this table and easy for verification. If value of A is 1, for all this 1, 2, 3, 4, all 6 are divisible by 1. So all these are divisible by 1. So we are making this one X. Next, for the 2, if the value of this A is 2, then all the even numbers will be divisible by 2. So we are making this 2, 4, 6 are divisible by 2 and this 1, 3 are not divisible by 2. So we are making this a no. 3 and 6 are divisible by 3. 1, 2 and 4 are not divisible by 3. Similarly, 4 is divisible by 4. 1, 2, 3, 4 and 6 is not divisible by 4. 6 is divisible by 6. 1, 2, 3 and 4 is not divisible by 6. Now which are here? Yes, will come under this set. So R in roster form is set of element with this. 1 comes with the all 1, 2, 3, 4, 5, 3, 4, 6. Therefore, 1, 1, 1, 2, 1, 3, 1, 4 and 1, 6. 2 will come with the 2, 4 and 6. So 2, 2, 2, 4, 2, 6. 3 comes with the 3 and 6. 3, 3, 3, 6. 4 comes with the only 4. So 4, 4. 6 comes with this only 6. Domain is, in this one, we have only domain as a 1, 2, 3, 4, 6. The range is 1, 2, 3, 4, 6. Let us see question number 6. Determine the domain and range of the relation R defined by R such that x comma x plus y, x belongs to 0 to 5. Solution. Given a relation R such that x comma x plus y, x belongs to 0 to 5. So, if value of x is 0, y value will be, this is x plus y value is x plus 5 is nothing but this y here 5. Next, value of x is a 1, x plus 5 value will be 6. If x is 2, x plus 5 is 7. If x is 3, x plus 5 is 8. If x is 4, x plus 5 is 9. If x is 5, x plus 5 is 10. Now, from this one, the relation R is such that 0, 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. The domain of R is 0, 1, 2, 3, 4, 5. Range R is 5, 6, 7, 8, 9, 10. Let us see question number 7. Write the relation R equals to x comma x cube. X is a prime number less than 10 in roster form. Solution. Given R is a relation such that x comma x cube, x is a prime number less than 10. As x is a prime number less than 10, so what are the prime numbers less than 10? 2, 3, 5, 7. So, if value of x is 2, then x cube will be 2 into 2 into 2. That is 2 to the 4, 4 to the 8. If x is a 3, then x cube will be 3 into 3 into 3, that is 27. If x is 5, 5 cube is 125. If x is 7, then 7 cube is 343. Therefore, the relation in roster form is R is equals to Set of elements is 2 comma 8, 3 comma 27, 5 comma 125, 7 comma 343. Let us see question number 8. Let A is equals to x comma y z and B is a set with elements 1 comma 2. Find the number of elements from A to B. Solution. Given A is having the elements x, y, z and B is having the elements 1 and 2. So, we know the number of relations from A to B will be 2 power n of A into n of B, where n of A is the number of elements in A, that is 3, and number of elements in B is n of B. So, we know that as per the given here, n of A is 3, 1, 2, 3 and n of B is 2. So, number of relations from A to B will be 2 power 3 into 2, that is 2 power 6. 2 power 6 is 64. Therefore, number of relations from A to B is 64. Let us see question number 9. Let R be the relation and Z defined by R such that A comma B and A comma B belongs to integers. A minus B is an integer. Find the domain and range of R. Solution. Given R be a relation and this Z defined by R with this such that is set with this A comma B such that A comma B belongs to integers and A minus B is an integer. We know that the difference between two integers is integer. Thus, A minus B is an integer. Therefore, domain of R is always integers. So, that is we will note it with this Z. Domain of R is Z. Next, range of R is also integers because always the difference also will be like integers only. Therefore, range of R is Z. Thank you.